Hi everyone, and welcome back to our channel. In today's video, we'll dive into how a vSphere standard switch can detect and respond to different types of network failures. Let's start with a relatively simple example. Here, we see an ESXi host equipped with a set of physical adapters, or VMNICs. Each physical adapter is assigned to a vSphere standard switch, and it's important to note that each VMNIC can only be assigned to a single virtual switch. Virtual switches cannot share VMNICs. In this diagram, we have a virtual switch with 3 VMNICs, giving it 3 physical uplinks to the physical switch. Our network is currently in a healthy state, with all 3 adapters connected and showing a green link light. Here, we have a virtual machine. When a virtual switch has multiple physical adapters, it will automatically utilize all of them, distributing the traffic across the adapters. For instance, this VM is currently using the first adapter for its network traffic. Imagine I send a training employee to tidy up the cables in the data center. Unfortunately, the training employee cuts the physical connection between the first VMNIC and the physical switch. This is a straightforward failure for the ESXi host to detect because the green link light on the adapter turns red, indicating the physical connection is down. The ESXi host will then take action by rerouting the traffic. It will reassign the VMs that were using the disconnected adapter to other available adapters. This is known as a link state failure, and it's the simplest type of failure for a virtual switch to detect and respond to. Let's consider a more complex scenario involving an upstream device failure. In this setup, we have 2 physical switches, with 2 VMNICs connected to one switch and the third VMNIC connected to the other. The 2 physical switches are interconnected. VM is currently using the third adapter for its network traffic and everything is functioning properly. Now, imagine that the training employer accidentally cuts the cable connecting the 2 physical switches. Although the physical adapters still show a green link light, the third VMNIC is now sending traffic into a dead end because the switches are no longer connected. This is where beacon probing comes into play. Beacon probing involves the physical adapters periodically sending out beacons to check their connectivity. In this case, the top 2 adapters can send and receive beacons through the first switch without issue. However, the third adapter's beacons are not being received because the second switch is isolated. The ESXi host detects this lack of beacon response and marks the third VMNIC as down. It then reassigns the VMs using that adapter to other available adapters, ensuring continuous network connectivity. Let's recap what we've learned today. A VMNIC is a physical adapter on an ESXi host, and each VMNIC must be assigned to a specific virtual switch. Virtual switches can't share VMNICs. If a virtual switch has multiple VMNICs, it will utilize all of them. The ESXi host can easily detect a link state failure when a green link light turns red and will stop using the affected adapter. For upstream failures, beacon probing helps the ESXi host identify issues further out in the network, allowing it to reroute traffic as necessary. Thanks for watching, and see you in the next video.